Hey, all right, there we are. Look, it is time for the show. Hi, it's me, John Park, and this is John Park's Workshop right here at Adafruit Industries Southern California Annex, my workshop. Welcome, and thanks for tuning in. I have all sorts of fun and interesting things to talk about today, so I appreciate you being here for that. Well, why don't we start it off with a little mention about our upcoming AdaBox, because guess what? No, that's the wrong thing. There we go. Just when we thought we still had some time left before the next one, geez Louise, there's only 24, only 24 days and 7 hours and some minutes and some seconds until the next AdaBox starts shipping. So go ahead, and if you were interested in subscribing or you're interested in signing someone up, this is going to be the AdaBox 14, which comes out in December. It'll be holiday themed, and it'll be super excellent. We promise. That's our guarantee. Super excellence. That's what we strive for, at least. So go and check it out. That's what I have to say about that. Now, this sign that I jumped all over a second ago, this is our Help Wanted sign. And not only are we looking for help, but other people are looking for help. So if you check out jobs.adafruit.com, you'll see that right here up at the top we have a bounty out. We're looking for someone to help with some filtering. So check that out. This is to help with some of the filtering of our PDM microphones, and I think we want to improve our filtering and share it with the world, so we're going to pay to help get some of that code taken care of, and of course, like everything we do, it'll be released open source, and it'll be out there for the world to enjoy. And some other interesting job openings there. For example, computer science teacher at Saigon South International School in Ho Chi Minh City, District 7, Vietnam. There's that, and many other interesting positions. So go to jobs.adafruit.com and check it out if you're looking for work, or if you want to sign up. All you need is an Adafruit account, and it doesn't cost anything. It's totally free, and you might post a job opening there if you're looking to hire someone, or put in your info if you want to get hired. So let's see. You know what this takes us to is our coupon code for today, which was a totally new word to me as of last night, and I still have no idea how to pronounce it, but a robot on YouTube told me it was pronounced testudinis. And that is our 10% coupon, testudinis, which is the order of reptile that our friend the turtle hangs out in. If you're looking for some classifications. That's where the turtle is. The testudines. Weird name, huh? So that's going to get you 10% off in the Adafruit store on your whole cart full of stuff. So go find some interesting things, and if you want to save a little money, that's how you're going to do it. Testudines, T-E-S-T-U-D-I-N-E-S. It's not catchy at all. Not a catchy word. Well, maybe it is. Maybe it's in my head now. That will not work on gift certificate subscriptions or software, but it is good on all the physical goods and things that you can get in the store. So go enter that on checkout. All right. Well, hey, since I mentioned the store, oh no, there's a weird background buzzing in the audio, is there? Huh. Well, let me see if this helps. I'll unplug that thing there. And I have no other guess what would be causing a weird background buzzing, because all my things are set down, all my other channels are set down to 0. So let me know if that fixed it. You say it doesn't, eh? Let me put on some headphones and see if I can hear it. It's probably, oh yeah. Well, that I hear when I put that up. Hey, hey. That's a mystery to me, other than this level's a little high. That's down. Yeah, I don't know what to tell you. You think it's the radio mic? Am I down on batteries or picking up interference? Well, these are at a high level of signal and battery, so I'm going to not suspect them, but it could be something else. Oh, yeah, cable. All right, maybe it is. I've got some cables laid across each other in new and interesting ways, and every time you do that, you beg for weirdness. Let me try to. Yeah, on my channel, on my mixer channel. Thanks for sticking with me while we troubleshoot this. All my mixer channels are down, other than the one I'm using, and I'm just gonna. Whoa, let's see. Am I still making sounds good? Because I just dropped my mic receiver back. It's on a tiny little tripod. It's not so stable. All right, you stay there. And I think I have some new cables plugged in that weren't. And you think it's the mic pack? It changed when I handled it, huh? Why would it want to do that? This is in nicely. All right. Let's set this further away. Dollar store cables. All right. How's that sound now? Still there. Let me try this. That didn't fix it. What about this? And that didn't fix it either. Oh, this cable. Something is super unhappy about how I've got things plugged in. Sorry about that. I've got some kind of ground loop, maybe. I hear it. Ooh, that's improving it. I improved it a lot. How's that? Oh, it's back. I'm amazed I haven't had this problem before. Yeah, it's definitely a cable shielding issue. I have a lot of crisscrossed things running across all over the place. Oh, it's getting pretty bad. Sorry about that, people. That is a little better. No, it gets worse when I get away from it. Well, I'm afraid I'm just going to have to torture you with that hum. Sorry about that. It's just how it is today. I'll have to troubleshoot that. That's weird. I haven't had those problems before. All right. Well, let's get back to it. So, where are we? I want to talk about a product of the week, and that is this little guy. And maybe this little guy is causing the problem. I don't actually think it is, but it is our LiPo charger for the USB-C. So we've carried these little USB LiPo chargers before, and this one is a USB-C one. And not only does it allow you to plug in with USB-C as you start to find these in more and more of your devices and have more and more of these cables around. That'll be handy. But it's also a breakout board for USB-C. So it's got the power and data pins broken out there. So you can put this on a breadboard if you're looking to do something, some prototyping with USB-C. That's going to be pretty handy. So I'm going to unplug that and move that far away in hopes that that'll fix something. And in fact, I'm also going to unplug these headphones from my mixer. And hope that gets it a little better. I will unplug each thing as I test it. How about? So that's product of the week. Go check it out. USB-C, LiPo charger, and breakout. And that'll bring us to the MakeCode Minute. Well, let's get set up here for our MakeCode Minute. Bring up I had just set these over here, but as I move things and fix stuff went out of whack. All right. So for the MakeCode Minute today, jump over here. There we go. I want to show you a little sort of minute-to-win-it game timer. So there's a lot of these games that you can play, especially with family and friends around the holidays, where you might want to have someone answer a question first based on trivia, or who knows what you're up to with these games. But a lot of games where you have to have someone buzz in or raise their hand first. And so what I decided to do was build a little timer using a Circuit Playground Express inside of MakeCode. And why don't we have a look? I'll demonstrate it first. So here you see I have an alligator clip attached to one of the capacitive touch pads just to kind of pull this off and away into the side of the board. So when I touch this, it's going to start get that started. Oh, I don't know if that got disconnected. Let me oh, you know what? It's actually been already started, so let me reset the board. Okay, so when I press this, it'll run through. You can hear it beep. Okay, and now it's ready for one of these two buttons to be pressed. So two people on either side or with a finger ready on the button. Whoever hits it first, it's going to light up to their color. So the person on this side with the button A gets red, and nothing else can be pressed at this point. So once one's buzzed in, the game locks it out. And now I'll press the alligator clip again, go a second try. And now this player with the B button, if they press it first, it goes to blue. So the way this is done inside of MakeCode, I can hide that now, it's fairly straightforward. So I have a couple of variables called ready and started. And at the beginning, we are ready, but we haven't started yet. When you touch the A4 capacitive touch pad, it checks to see, has the game been started? And if not, then it can proceed forward. And this prevents double taps of the start button. And then when we do start, we flip that value to true, and then 3 times we run through a little bit of animation and play a tone, beep, 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 and then beep is the high one that ends it. And then we set the ready state to true. And this variable, when it's set to true, allows one of these two buttons to be pressed. So there's this if loop that says if ready is set to true, then we can go ahead and pay attention to what happens when the buttons are hit. And then depending on which one is pressed first, we set the ready state to false, so the other person with the other button can't weigh in at this point. We set the pixel color to the color for that button, and then we set the started loop to false. And so that'll allow us to reset it after the next time. And so that's how you can create yourself a little game timer using the Circuit Playground Express inside of MakeCode. And that is your MakeCode Minute. All right, how are we doing? I'm going to check the Discord. Let's look in and see what are people saying about the state of this audio. Let me bring mine up so I can read it. Any thoughts? Is it still? I think you're all people over there. Yes, I do, Mr. Certainly. Let me plug in my headphones again and see. I'm also going to unplug this Circuit Playground Express that I just used for that demo, just in case that was contributing to it. No, I still hear that buzzing. What has happened? What changed? Yeah, it's definitely... Ooh. The pack in my pocket. What has happened here? It's a little quieter when I hold that, isn't it? Or when I hold both of them. So that sort of says ground loop issue to me of some kind, which is super weird because I have not really changed much of anything on here in a while. Let's turn the gain down on that channel too. All right, well, let me know if it's unbearable and I will just proceed with charades. Still buzzing. You thought it was the pack. All right, I'm gonna hold this pack right here. It gets louder as you move reach to your left. What's happening over there? I don't know what's happening. All right, well, let's now move on to this section of the show that I like to call the MakeCode Arcade Game of the Week. And I'll bring up my browser here again. And this is my pick for this week. It is called Pumpkin Drop. And yes, I realize that we're technically past Halloween, but we are still sort of in a grace period of autumnness. And so Pumpkin Drop by Shack Attack 8. Shack Attack 8 is back again with another cool game. So let's take a look at the game first. This is a, well, I'll let the instructions explain it. It says press A to drop your pumpkin. If it lands in a cart, you get points. If you hit multiple carts in a row without a pumpkin hitting the ground, you get chain multiplier that multiplies your score. All right, and so here it is. We have this little sort of claw holding a pumpkin up at the top, and when you click A, it drops a pumpkin, and the pumpkin lands in one of the carts, or it hits the ground, depending on your aim. So you can see I had one hit the ground. No exploding pumpkin animation, though. It just disappears, possibly, thankfully. And so that's the game. It's a really cute game, really nicely executed. I haven't seen any games like this done before in MakeCode Arcade. And so I just wanted to point out a couple of neat things inside of the code. So first of all is the motion. And I'd never thought of doing it this way, but it's a really elegant solution for having the player sprite, which is this claw moving back and forth. The way that's taken care of is just with these blocks right here. So it's set sprite to bounce on wall, that's turned on. And so you can imagine that's a sort of that block has a whole bunch of code and functionality built into it, bit of a black box for some physics stuff that's happening. And then we have this set my sprite's velocity on X to 50. And so it just starts the game heading to the screen right, which is the positive X vector there. And then when it hits the wall, when it contacts it, the bounce on wall sprite allows it to go and essentially reverse that direction. And you can do angled things as well. You can bounce stuff all around. But this is a really neat, elegant use of just that one axis since it's moving perfectly perpendicular to those walls. And the other interesting thing is you can't spam the shoot button, the A button, to drop a bazillion pumpkins. And the way that's done is with this little cooldown variable. So there's a cooldown variable that's set to false, and when you release a pumpkin, it gets set to true, and whenever you hit the A button to try to drop a pumpkin, it checks, are we in cooldown mode and you gotta wait a second, or has the pumpkin particle or projectile been destroyed or hit one of the carts, meaning that it's out of play. And so that little cooldown is a really nice, elegant way to prevent the player from just spamming the button a million times. And I just to play around with it, I built a little very simplified version of it. You can see here, this is the logic for the moving back and forth that I've duplicated, that Shack Attack 8 created, as well as I have a little projectile there. And I didn't set a cooldown period, so I can spam the heck out of that button, which is a lot of fun. And you can see this could make for some interesting gameplay, sort of a variation on a Space Invaders type of theme, except where you're not in control of the movement, just on the shooting. And so that is my arcade game pick of the week, which is Pumpkin Drop by Shack Attack 8. Go check it out. That is the MakeCode Arcade Game of the Week. All right, hey, maybe things will get better when I move around to the other side of the workbench. I'm going to head over there And let's take a look. In fact, I'm going to put that there. Let's take a look at our project this week, which is, oh, by the way, I just realized I have my phone really close to my pack. Did that do it? Darn it. I usually take my phone out of my pocket. That can definitely cause. Oh, so it's a fun radio interference. Let's see. Maybe. That's a different interference. Not sure. All right, well, I'm going to need the phone because we're going to use this for Bluetooth here. And the reason is I've got the Bluetooth LE version of our Circuit Playground. This is the Circuit Playground Bluefruit. And I have it attached to a Crickit board, which is our favorite little robotics board, which handles motor drivers and servos, and you can do external NeoPixels with it. It has a little amp for doing external sound, as well as some different I/O. And with the Circuit Playground Bluefruit connected to the Crickit board, running some CircuitPython, some fairly simple CircuitPython code, I can control the two motors that I have under here with the Bluefruit app. So let's go ahead and pop up the Bluefruit app. And that's it. And so you may be able to see there what it's asking for right now is a connection. It has found an available Bluetooth LE item that has UART enabled. That's how it's filtered. And I'm going to go to this controller section and to the control pad. And here I have a convenient little set of D-pads as well as 4 buttons. So I've coded this so that the first NeoPixel here goes blue when we're connected. So it's a way for me to tell that I have a connection to the board when I first start. And then I can press buttons 3, 4, and 2 here just to change the colors of the NeoPixels. And that I've left in there just as an example. If you want to go and change that code, you could pretty simply change how those buttons are being interpreted to do other things, such as move some servos on the board, or maybe play a sound with a WAV file. And then the D-pad buttons will allow my turtle here to turn. Let me zoom out a little so you can see. Either left or right. And on Lamore and Phil's suggestion, I've slowed that down a lot. So the way this works, this is sort of like skid-style steering on a tank, where if I turn to the right, what I'm doing now is I'm only rotating the left wheel forward, and I'm actually hitting the brakes on, or just not engaging the right wheel. Previously, I was sending the right wheel in reverse and the other wheel forward, and that spins at sort of twice the rate, I think. And then forward is both motors at the same time, as is reverse. And so that I've actually also adjusted my code so that it only drives while you hold a button, so it's very easy to start and stop. Previously, it was a bit more of a exercise in speed and dexterity and trying to get this to go where you want it to, because it went so fast, and you had to hit the stop button a lot. So that is the project built. So let's take a look at how I built it. First of all, we've got what's going on underneath. There's sort of 3 or 4 things of note down here. 2 of them being these little DC motors. And these DC motors, zoom in a little closer for you. So these DC motors are plugged into 2 separate motor driver ports on the Crickit. And you can either in the physical world, or in where you plug them in, or in software, come up with a scheme where they both go forward when you want them to both go forward, and both go backwards when you want them to both go backwards. So in this case, since they're kind of mirror images of each other, I think I just reversed their polarity of their plugs. So I have essentially power ground and then ground power going into those ports. But if you plug it another way, you can always change that in software. And then this is really cool. I mentioned this last night on the show and tell. This was a suggestion of Lamore's. We've done previously, when the Crickit came out, I did a lot of projects using a 2 or 3 AA or AAA battery pack. Actually, was it 3 or 4? I think it was a minimum of 3 to get the voltage required if you're using alkalines and 4 if you're using nickel metal hydrides. And that's because we want to run at about 5 volts, and we want some decent amperage for the Crickit to be able to turn those motors without stalling out. And when you stall out, you also risk rebooting the whole system, getting these little brownouts and stuff. So we want ample power. And so Lamore's suggestion was use one of these little, we call them like lipstick form factor battery chargers for a phone. And this supplies an amp at 5 volts. And I think it's a 2200 milliamp hour battery in there, just like those cylindrical blue batteries that we sell. I think that's what's inside. And you just recharge it by plugging it into a micro USB there. And the reason this is actually straightforward and convenient, which you might not think it is because we have a barrel connector on the Crickit and we have a USB connector on the phone charger. And that's because, I turn this off here, we happen to sell a little cable that goes from a USB to a 2.1 millimeter center positive DC barrel jack. So we can kind of blend worlds there and go right out of the USB power and into our Crickit, which powers the whole thing. And then the chassis on this is actually the exact same one. This is really is it, not just the design, but this is the one that I built for a previous Crickit project, which was the Crickit Carnival bot, little tail dragging robot here made out of cardboard. And you could use a similar chassis to this or any sort of stiff material, but I'm using cardboard in this case, which allows me to sort of center most of the weight in the middle here. You see I've got my board over the wheels and I've got my battery pretty much centered there. It's a little towards one end. And since we're not really going for great speed or accuracy with this, I don't even have a sphere back here, like a little bearing. Sometimes you'll see people put a bearing back here, or I've previously done it even just with a paperclip to get low resistance or low friction and drag. But instead, we just have our bot, when it does a little bit of a wheelie here, it'll drag on its tail a little bit and then sort of right itself, and it'll bump its little front bumper here on the ground. So it's a pretty straightforward design for the chassis. Like I say, you could substitute that for nearly anything. And the way I've attached most of the things here is just with double stick foam tape. And this I've got with some Velcro. And what I have on top just for decoration is a little piece of felt. And one suggestion that I had from Phil is that we add some feet to this guy. So I've got some cardstock here. I've also got some EVA foam. Let's try it actually. We'll try it with the foam. You'll be able to see that because it's yellow. And we just started carrying foam in the store. This is some that I had from the craft shop, but it's probably pretty similar. I think it's 2 millimeter thick foam. So what I'll do, let's zoom out just a little bit more. What I'll do is draw out a little foot with an attachment that we can put on the wheel and see if we can get kind of a flipping flipper. I might exaggerate the size a little bit. Something like that. And I'm just going to cut that out with some scissors. And this is totally experimental. I have no idea if this is going to work, but the idea is it might be fun to have some little flippery, turtley feet attached to the wheels. And I do recognize that turtles are quadrupedal, but not this guy. Let's leave a little extra tab on the end there too. And so the idea is just to have this flipping and flopping as he goes. So I think I'm going to go old school here and simply hot glue that on. So I've got my hot glue gun kind of warmed up and ready to go. And we'll just apply a blob of it there. And hold it to there. And then I can use my old favorite trick, which is upside down canister of compressed air, which instantly cools your hot glue and fixes it there. So why don't we try this, and then the idea I had was to put them on opposite sides so it looks like kind of every other foot type of gate instead of both at the same time, which would be a little more froggy-like. What do we say these guys are called? What's their classification? What was our coupon code of the weak testerdine, something like that. All right, let's reconnect here. Zoom a little further out. And connect the controller. Here we go. Oh yeah, that's kind of cute. I like that. All right, I'm sticking with that. That's adorable. Yeah, very cute. All right, so I will continue with that. I'll be working on the guide over the next couple days, and we will end up with some design files in the guide that you can print out if you want to cut out, or you can choose to make your own shape. By the way, I forgot to mention that is just some felt, some craft store felt that I was using, but I think I'll switch it over to the green EVA foam. And let's see, how are we doing? How was the sound? Did that improve anything? I'm just dying to know. So let's test this. Nope, still have that hum. That is weird. All right, I need to hire an audio professional to come over here and fix this for me. I'm out of ideas. All right, well, that just about does it for the show. I will, let's just take we have a minute. I'll just take a little quick look if you're interested in the code. So here we are. Yeah, why don't we look at this in Atom. And I will zoom this up a bit so it's a little easier to see. All right, you might be able to see that. So most of this is in the Adafruit Crickit library and the BLE and Bluefruit Connect libraries. So you can see I'm importing those packages there. And from the Bluefruit Connect, we've got the button packet. We also have the color packet, so I can use the color wheel, although I haven't assigned that to anything. And that means that when this is connected between the app, which is on either Android or iOS, to the device, then it will allow the device to receive packets that contain either RGB color values or these D-pads and 4 buttons. Then I am setting up my little onboard LED, so that's this D13, the famous old standby D13 board ever since the days of the original Arduinos. That one has a red LED on it, so I light that up whenever I press or essentially receive a command from Bluetooth, just so that I know that it's received something, it blinks. And we are setting up our motor objects, so this is part of the motor library, so I have these 2 ports, 2 DC motor ports there, 1 and 2. And then I'm setting my forward speed, so this is set at 1/4 speed, so 0.25. And that's about as low as you can go before these motors will stall. So you can definitely go faster. You can go to 1, I believe. Just to 1, right? I don't think you can go higher than 1. Maybe you can. I can't remember. And then I'm setting up my neopixels as well as some stored color little tuples here of some colors that I might call just by name. And then we do the setting up of the UART server on the Circuit Playground Bluefruit, and that's what the app will connect to. And then when it's in waiting, we have that first LED black. When we get connected, we turn it blue. And then we watch for packets. And then that's pretty much the rest of the logic. So this is what happens when buttons are pressed. And so if the button packet is the button packet.up, then I turn the throttle to forward on both wheels or both motors. And if it's the down button, I hit the reverse, which was that variable I had set before. I'm also setting some colors. I'm filling with colors as I do that. And then I have my left and right. And here's, as you can see, this is, I kind of put these out of order, but fix that order. When I turn to the right, I set the motor 1 throttle, which is the motor on the left, to forward, and I just stop the right motor entirely. And then the opposite is true when I go to the left. So these are just to keep this consistent. Motor 1 is stopped, which is the left motor, and motor 2 goes forward, and so we turn spinning to the left. I have a stop button. That first button 1 will actually just set both throttles to 0, and that's less necessary now that I'm using this button up behavior. The other buttons will just set neopixel colors, but this is how I'm using that, which is we actually not only read when a packet when the button is pressed on the phone app, but also when the button is released. And so right here we have if the packet is button packet up, the button has been released rather than pressed, so it's not a press packet, but we're still receiving info from it. That's because it's been released. Then we set the throttles to 0, essentially hitting the brakes on all of those. So that's why we get that hold to drive and release to stop. And that about covers it. It's fairly straightforward. And like I said, I'm using some of these just to set colors. So you could co-opt those for doing things with servos or magnets or sound, NeoPixel strips, anything you want to plug into the Crickit you can use. And all right, well, I think that about does it for our time. Let's take a look over in the chat. I want to thank everyone for coming out, and also say hi to the people over in the YouTube chat. Hello, hello. And someone asked about the IDE I'm using. Yeah, I'm using the Atom IDE, A-T-O-M, which is what I was just showing you there. I like that. It's the main text editor that I use for Python. Even sometimes when I'm coding in Arduino, I'll use this. And you can hook it up so that it can be the external editor for Arduino and still save and push it up to the board. But yeah, I like that editor, and then you can pick some cool color schemes and all that good stuff. Let's see. Yeah, someone asked, Michael Clare says, maybe some smoothing or slowing the motors so they don't do jumps or hops so much. Some PID, perhaps. Yeah, great idea. There's definitely code, great example code out there for sort of PWMing, like slowly incrementing up your speed and down. The main problem is that these don't really do much below the 0.25 level, but you can, I think, make the transitions a little smoother than what I have here. Here it's just on and off, so it's definitely jerky. Let's see, what else? Oh yeah, thanks, Mr. Certainly. I don't know if I've showed that trick before with the compressed air, but it's just your regular old compressed air canister. You get, this is dust off, duster. And when you place these upside down, you get some really chilled propellant coming out, and it just hardens the glue almost instantly, which can be really helpful because sometimes you may have soft materials you don't want to, if you're using like PLA plastic you've 3D printed and you want to use hot glue but you want to instantly chill it, that's how it cures, is with chilling. I've never had any downsides to that. Any other little tricks you know of off the top of your head? That is my #1 trick with dust off. The others just use it as directed and dust things off. Yeah, you can definitely freeze stuff with it. You can freeze your fingers with it, so be careful. That is definitely off-label use. All right, so before I go, I will mention again, we have a coupon code, Testudinis. Testudinis? Testudinis. Weird word for turtle. And that'll get you 10% off in the store. So go to the Adafruit store, buy a bunch of stuff, throw it in your cart, and on the way out, type this in, 10% off. Awesome. All right, thank you all so much. Thanks for putting up with my buzzing audio today. I am very sorry about that. I will have to try to fix that before next week. And a couple notes about next week. Next week is Hackaday Super Conference at the end of the week. And our own Scott Tannute Shawcroft will be in town because he's giving a talk at Super Conference, Hackaday Super Conference in Pasadena. And since he's here, he's going to come and be a guest on the show. So we will have a guest Scott on the show next week, hopefully without any buzzing microphone sounds. Otherwise, we might have to hire Mr. Cedar Grove to come down here and do audio for us. And we're going to talk about some fun stuff with CircuitPython, maybe some MIDI, maybe some Game Boy CircuitPython cartridge stuff, Bluefruit things. So please come on by and let me know in the chat if you have any questions and things you'd like us to discuss when he's here. So that'll be a very special guest on John Park's Workshop next week. All right, that's all I got. Thank you all so much, and I will see you next time.